Hello, and welcome to my Week 5 presentation on the Haber process and a new catalyst patent pending. My name is Peyton Bean, and welcome to my presentation. First, we will start with our agenda, and we will go over many aspects of this process, the process itself, any concerns, and ultimately rejecting or approving this process. And we'll start with an introduction, we'll go over a brief history, we'll talk about some areas of focus, and then we'll finish with our summary. So today we will be discussing the Haber process regarding a new catalyst awaiting a patent and whether we should approve said patent. This will include discussions of the process in terms of kinetics, thermodynamics, as well as equilibrium. And first I would like to take you through a brief history on the actual Haber process. So in 1913, Fritz Haber, a German chemist, developed the Haber-Bosch process, which is a method for producing ammonia, or NH3, from nitrogen, N, and hydrogen, H, to manufacture artificial fertilizer, or ammonia. This process, however, is considered controversial and due to its pollution of ground and drinking water that can bioaccumulate in food chains, and we will discuss this further later on. Okay, so today we have a couple of areas of focus that I want to go over in terms of kinetics, thermodynamics, equilibrium, and whether we are going to reject or approve the patent. So first we're going to start off with kinetics. Transition metals are almost always used to catalyze the Haber process. Most often, industrial chemists use magnetite and iron oxide with smaller amounts of potassium hydroxide. Other common catalysts include chromium and osmium oxide. So that is, in terms of kinetics, how the Haber process uses catalysts. Next, we will dive deeper into thermodynamics as it relates to the Haber process. So the reaction of nitrogen with hydrogen produces ammonia, which is what we're looking for in this actual process. This reaction is reversible and exothermic, so with that, high yields of ammonia are favored by low temperatures, and we'll get into why that's important here in just a moment. Next, we will discuss equilibrium. And in terms of equilibrium in relation to the Haber process, the forwards reaction is exothermic, like we discussed with thermodynamics. And the reverse reaction is endothermic. This means that as the temperature increases, the position of the equilibrium moves to the left, also known as Le Chatelier's principle. And so the yield of ammonia is actually decreased. So that gives us the position of ammonia to the left, again, like Le Chatelier's principle. So after discussing kinetics, thermodynamics, and equilibrium in terms of the Haber process, this new catalyst that is being approved or rejected by this patent should definitely be considered. Due to its controversial nature of the original catalyst for the Haber process, we can and should replace that catalyst by approving this patent for the new catalyst. And in addition to whether or not we should reject or approve the patent, like I said, we should definitely approve a new patent for this new catalyst in terms of the Haber process due to its controversial nature, not only with the actual process itself, but also the implications, as we talked about earlier, with pollution from those transition metals in groundwater, which is extremely important that we find something new that doesn't off-put those emissions. I also wanted to add a very important quote by Fritz Haber himself, who was definitely an innovative and brilliant man. He states, "Agricultural husbandry essentially maintains the balance of bound nitrogen," which I found throughout this entire research project to be very, very poignant and really inspiring. So in summary, with what we have discussed in mind, we can hopefully come to a consensus on the actual approval of this patent of the new and improved catalyst. After much consideration and research, the new catalyst for producing ammonia can provide a sustainable future for agriculture in terms of the simpler chemical process. And again, this is relating to the Haber process. So this new patent will replace the original patent and hopefully offset emissions and high energy using that low temperature process that yields more ammonia and gives off less emissions. And then we have our reference pages, and I hope you guys enjoyed this presentation, and thank you so much for watching and listening on the Haber process.